Hello, all of you. This is Amit Burte, and welcome on my new channel that is Mystery Wali Chemistry. Okay. In this channel, we study some concepts, basic concepts, as well as some MCQs as far as your CT exam is concerned or related to that CT exam in my channel. Okay, so today we're going to study one important concept in organic chemistry and is the ozonolysis, right? Yes. So you have heard this term ozonolysis, particularly in hydrocarbons. Okay. Now all of you know that hydrocarbons are mainly classified into two types. Hydrocarbons are mainly classified into two types. That is, hydrocarbons may be unsaturated hydrocarbons or they may be saturated hydrocarbons. So this reaction or this process, it helps us to predict or to locate or to identify the position of carbon carbon double bond or even carbon carbon triple bond in organic compounds. Okay, yes, this reaction is mainly used to identify the position of carbon carbon double or triple bond. So unsaturated hydrocarbons includes alkenes, and alkynes. Alkenes and alkynes, while saturated includes alkanes only. Alkanes. Okay, right. So today we want to discuss this ozonolysis, and our reactants are going to be either alkenes or alkynes or even cycloalkenes also. So let us see what is this ozonolysis. Ozonolysis, as the name itself indicates, that it is the breaking, because here lysis or lysis means what? It's a breaking or cleavage, we can say. That is rupture. Okay, so breaking with the help of ozone, it becomes ozonolysis, right? Okay, and our reactants are, yes, they are unsaturated hydrocarbons. Unsaturated hydrocarbons. So when unsaturated hydrocarbons are allowed to react with ozone, now this reaction occurs in presence of organic solvent, and particularly inert solvent like CCl4. We can use here carbon tetrachloride as a solvent, so that it gives one intermediate compound, and that intermediate compound is known as ozonide. Ozonide. And this ozonide on further decomposition finally gives either aldehydes or ketones or carboxylic acids or anhydrides or even alcohols also, primary or secondary alcohols, and that depends on the cleavage of this bond, cleavage of this intermediate compound, that is the ozonide. You can cleave this ozonide by two ways. Either you can carry out here reductive cleavage. reductive cleavage reductive cleavage of this ozonide, it leads to aldehydes or ketones. Okay, and this oxidative cleavage, second cleavage is the oxidative cleavage. So this oxidative cleavage, it leads to carboxylic acids or anhydrides or anhydrides. Now reductive cleavage not only leads to aldehydes or ketones. In some cases, we know that ketones are stable towards oxidation reaction, but aldehyde gets readily oxidized. Okay, similarly, aldehyde gets readily reduced to corresponding primary or secondary alcohol. So if you use here mild reducing agent for cleavage of this ozonide, then that results into either aldehyde or ketone. And if we use here some other reducing agents, strong reducing agents like LiAlH4 called lithium aluminum hydride or NaBH4, that is sodium borohydride, then it leads to alcohol, which may be primary alcohol or maybe secondary alcohol. Primary or secondary alcohols. Okay, so it's about this reaction in a rough manner, ozonolysis. That is the reaction of unsaturated hydrocarbons in presence of ozone by using ozone in presence of CCl4 to form intermediate compound that is called ozonide, which on further decomposition or which on further cleavage, either oxidative or reductive, leads to either aldehydes or ketones or carboxylic acids or acid anhydrides or primary or secondary alcohols. So the reaction is called ozonolysis reaction. Okay. Hope you got some idea about this, rough idea about this ozonolysis reaction. So let's have some examples so that you can get better idea about this ozonolysis reaction. Let us start with this alkene, that is CH2 double bond CH2. CH2 double bond CH2. It's the well-known alkene or the first member of this alkene series known as ethene. Ethene is the IUPAC name of this alkene, or it is also called ethylene. Ethylene. Ethene or ethylene. So this on a reaction with ozone that is O3 in presence of CCl4 as a solvent. First of all, it gives a compound having a typical structure, and I call this typical structure, or if you observe this structure, then it look like hut, right? It look like hut. So that's why I call this reaction, the first step of this ozonolysis reaction, as a hut formation reaction. Okay, remember that here is no any covalent bond present between two carbon atoms, because if you check the valence of these two carbon, then the valence of both carbon is already satisfied, 2 3 and 4, 2 3 and 4. Okay, so it clearly indicates that one molecule of ozone can break two covalent bonds. Okay, one molecule of ozone can break two covalent bonds. Good. So remember, then in next step, suppose if I carry out reductive cleavage of this by using zinc and water. Zinc is a mild reducing agent. Now instead of zinc, one can also use this compound Me2S, that is dimethyl sulfide, that is CH3 two times and S. It's a dimethyl sulfide. You can also use here this compound PPH3. Now all of you are familiar with this pH. pH means what? Yes, it means phenyl or phenyl with formula C6H6, C6H5. C6H5 means what? It's a phenyl. Okay, and the parent compound of this compound is a pH3, like NH3. It's a pH3, and this compound is known as, it is called phosphine. It is called phosphine. So therefore, if you consider this as a derivative, it is a derivative of this compound called phosphine. So therefore, this compound becomes triphenyl phosphine. Okay, it's a triphenyl phosphine. So instead of zinc and water, you can also use any of this compound, and all these are mild reducing agent. It's a dimethyl sulfide. It's a triphenyl phosphine or triphenyl phosphine. So let us see reductive cleavage with the help of this zinc as a reducing agent. So here the role of zinc is a reducing agent. So what will happen? This intermediate compound, now this intermediate compound is known as ozonide. It is called ozonide. It undergo cleavage like this. It undergo cleavage like this. So what happens? This OO bond undergo complete cleavage. This CO bond as well as this CO bond, they also undergo complete cleavage. So CH2 will be with what? This oxygen. CH2 with oxygen, that is CH2O. Now CH2O means what? Yes, it's a formaldehyde. And from this side also you'll get same CH2O. That is O means C will be doubly bonded with what? Oxygen. Here also C will be doubly bonded with oxygen. So you'll get two molecules of formaldehyde. You'll get two molecules of formaldehyde, that is H, then C double bond O and H, two molecules of formaldehyde. Now, why we're getting two molecules of same aldehyde? Because our alkene is a symmetrical alkene, right? Okay, how to identify whether the given alkene is symmetrical or unsymmetrical? Or to check the substituents present on that two unsaturated carbons. So here, these two carbon carries two same type of substituents. Both carbon carries two hydrogen atom, meaning this alkene is a symmetrical alkene. So if alkene is symmetrical, we'll get two molecules of same carbonyl compound, and here carbonyl compound is the formaldehyde. Okay. What about this third oxygen? Now, this third oxygen is going to couple with this zinc, producing zinc oxide, that is ZnO. And as this decomposition is carried out by using zinc in presence of water, so this zinc oxide, it readily reacts with water, producing zinc hydroxide, giving ZnOH twice, that is zinc hydroxide. So this secondary or the minor product of this reaction is the ZnOH twice. Got it? Okay. Yes, so it's about ozonolysis reaction of ethene or ethylene. Let us have a couple of more examples. Now, if I start with this CH3, then CH double bond CH2, CH2. It's the next member of alkene series called propene. Okay. And when this propene is allowed to react with ozone, that is O3 in presence of CCl4, again, first of all, it is going to give us what? Same compound, intermediate compound, that is ozonide. Addition of ozone occurs across carbon-carbon double bond. Okay, it's addition reaction of alkene. Remember. So and again, one molecule of ozone can break two covalent bonds. So both these carbon-carbon bonds, double bonds, they undergo cleavage, complete cleavage, giving intermediate compound, which will be like this: CH3, then CH, then O will get heart-like structure, then CH2, then O, and then O, and then dash. Okay. So again, this intermediate compound becomes what? It's a ozonide. It's a ozonide. And then in next step, when it undergo reductive cleavage using Zn and water, that cleavage will occur like this. Okay, you get CH3CHO, that is acetaldehyde, and from this side we'll get CH2O, that is formaldehyde. So in this case we're getting two different aldehydes. Yes, we're getting two different aldehydes. Correct, because our reactant, that is alkene, that is propene, is not a symmetrical alkene, right? You can check symmetry of this alkene. Here, this carbon carry one hydrogen and one methylene group, and this carbon carry two hydrogen atoms. Okay, so as the substituents on these unsaturated hydrocarbons are not same, so therefore this alkene becomes unsymmetrical alkene. Okay, yes, and in addition to these two, we'll get our secondary product, which is the zinc hydroxide, ZnOH twice. ZnOH twice. Are you getting my point? Very good. Let's have one more example. CH3, then CH, then double bond, CH, then single bond, CH3. Now this alkene is a 2-butene, that is butene. It's a butene. Again on a reaction with ozone in presence of CCl4 as a solvent, gives us ozonide, which will have structure like this: CH3, then CH, then O will get hut like structure, then CH, again same CH3, and here O, and then O. It's ozonide of butene. Okay, as the alkene is symmetrical, see here both carbon carry one hydrogen and one methyl group, meaning alkene is symmetrical. Okay, so in next step, this undergo reductive cleavage by using same zinc and water. So it gives us this compound. You get CH3, then CHO, that is C double bond O and H. CH3, CHO. Cleavage takes place like this. We'll get CH3, CHO and CH3, CHO. That is, we'll get two molecules of acetaldehyde, and this oxygen couples with what? That zinc, giving zinc oxide, decomposed by water, giving what? Zinc hydroxide, ZnOH twice. Okay, so you get two molecules of this compound called acetaldehyde. So it is acetaldehyde, that is formaldehyde, and these are formaldehyde molecules. Okay, so it's about ozonolysis reaction. It's a ozonolysis reaction. Follow? So let's have a couple of more examples so that get better idea about this ozonolysis reaction. Now suppose if I start with this CH3, then C, then CH3 double bond CH, then CH3. First of all, you guess the symmetry of this alkene. Yes, it is unsymmetrical alkene because the substituents of these two unsaturated carbon, they are not same. Two methyl group, one methyl and one hydrogen atom. Yes. And what of name of this alkene? One, two, three, four. So it's a parent alkene called butene, again butene, and on second carbon here is a methyl branch, so it becomes 2-methyl or 2-methyl, 2-methyl. It's a butene, 2-methyl butene is the IUPAC name of this alkene. On ozonolysis, that is a reaction with ozone in presence of CCl4 as a solvent. Addition occurs across this carbon-carbon double bond. So carbon, then CH3, then CH3. It's a CH3, it's a CH3, then oxygen, then carbon with hydrogen and with CH3 and two of the oxygen gets added at the bottom, giving this ozonide of this alkene. So it's an intermediate compound, and this on reductive cleavage by using zinc in presence of water. Cleavage takes place like this, cleavage occurs like this. Okay, so you get CH3, C, O means C double bond O and CH3. You get ketone, that is acetone, CH3, then C double bond O, and then CH3. But from right hand side, you will not get same compound. You will get different compound because alkene is not symmetrical. So from right hand side, you will get aldehyde CH3, CHO. So you get CH3, CHO, that is C double bond O and H, and plus that secondary product which is zinc hydroxide ZnOH twice. Okay, what it means? Products of ozonolysis are not only aldehydes, as I mentioned earlier in the general reaction, that is ozonide, which is obtained as an intermediate product after addition of ozone molecule on unsaturated hydrocarbons. That on decomposition gives us not only aldehydes, that also gives us ketone, that also gives us carboxylic acid, that also gives us anhydrides, and that also gives us what? In some cases, alcohols, either primary or secondary alcohols. Okay, so in this case, we are getting mixture of aldehyde and ketone, that is acetaldehyde and acetone are the product of this reaction. Okay, got it? Yes. Now suppose if I replace this hydrogen by CH3, this hydrogen by CH3, now alkene becomes symmetrical alkene. It becomes 2,3 dimethyl. It's a 2,3. It's a 2,3 dimethyl, 2,3 dimethyl butene, which is symmetrical alkene. So what will happen? Yes, this hydrogen gets replaced by CH3. Okay, so we'll get two molecules of what? Acetone. So we'll get two molecules of acetone, and plus we'll get that zinc hydroxide, ZnOH twice. Got it? Yes, very good. Let's have one more example. Same, I'm taking same alkene, CH3, then CH, then double bond CH2. Okay, it's a propene. Propene on a reaction with ozone in presence of CCl4, it gives ozonide having formula CH3, then CH, then O, then CH2, then O, and then O. It's ozonide. Now, if I decompose this ozonide by using any of these reagents, LiAlH4 or even NaBH4, that is sodium borohydride. Okay, first of all, this ozonide undergo cleavage like this. From this side, from left side, we'll get acetaldehyde, and from right hand side, we'll get formaldehyde. So these are the expected product, that is CH3, then C double bond O and H. Okay, and H, then C double bond O and H. These are the expected product. Okay, but the observed products are different because these reducing agents are not mild reducing agent like zinc or that dimethyl sulfide or even that triphenyl phosphine. These are strong reducing agent. Okay, so whatever the aldehydes will get after breaking of this ozonide, they gets readily reduced or they gets easily reduced by these reducing agents because these are strong reducing agents. So this we know that aldehydes on reduction gives primary alcohols, okay, in which the net effect is aldehyde group converts into primary alcoholic OH group, that is CH2OH. So CHO will convert into CH2OH, so you will get CH3, then CH2, and then OH, and in this case you will get CH3OH, that is methanol. So these are the product of this particular reaction. We will not get acetaldehyde, or reaction does not stop at that stage, but the product of this reaction becomes what? Ethanol and methanol. Okay, good, very good. Now, if I carry out oxidative cleavage, the oxidative cleavage is carried out by using particularly peroxide, like hydrogen peroxide, H2O2. It's a hydrogen peroxide. Now, this hydrogen peroxide is oxidizing agent. So, again, the expected product of this reaction are CH3, then CHO, that is C double bond O and H, and here H, then C double bond O and H, that is formaldehyde. But the observed products in this case are CH3, C double bond O and OH, and plus H, then C double bond O and OH. Okay, because we know that aldehydes are readily oxidized to what? Corresponding carboxylic acid. So these are the expected product, but as oxidizing agent is here, that is hydrogen peroxide. So this causes oxidation of this acetaldehyde into acetic acid, and formaldehyde into what? Formic acid. And again, in this case, let's observe this as a product. So this acid is a formic acid, and this acid is acetic acid. So this formic acid is highly unstable, so it readily decomposes into carbon dioxide and water. Okay, carbon dioxide and water. So you get CO2 and plus H2O. So it is a oxidative cleavage of intermediate compound, that is ozonide. Followed? Okay. Now if I have this alkene, hexagonal ring structure with one double bond. Yes. Now without double bond, compound is called cyclohexane. Now cyclohexane changes to cyclohexene. Cyclohexene. Now when it is oxidized by ozone, or when it undergoes ozonolysis reaction in presence of inert solvent, addition occurs across this carbon-carbon double bond. So you get this compound, you get heart-like structure. Okay, you get heart-like structure, that is oxygen, then carbon, then oxygen, then oxygen. You get this as an intermediate compound, and this intermediate compound on, say for example, reductive cleavage, zinc in presence of water, which takes place like this. It's a breaking of this intermediate compound. What will happen? This O will be along with this carbon, this O will be along with this carbon, this O couples with zinc, reacts with H2O, giving ZnOH twice. So we'll get this as a product. We'll get product like double bond O and H. And here also double bond O and H. Okay? Yes. And instead of this zinc, this zinc, if I use here H2O2, what will happen? This will oxidize into what? Corresponding acid. This will oxidize into this acid. Double bond O and OH, and double bond O, double bond O and OH. That is CH2, 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 means CH2 four times, CH2 how many times? Four times, and two carboxyl group. One over here, it's a carboxyl group, and other over here. This acid is known as adipic acid. It is called adipic acid. Means cyclohexene on ozonolysis gives ozonide, which on reductive cleavage gives us 1, 2, 3, 4, 5, 6. We'll get hexane diol. Okay, it's a hexane diol. It's a hexane diol. That is 1,6 diol, and which on oxidative cleavage gives us what? Acid, dicarboxylic acid. That is adipic acid. Okay, got it? Yes, very good. Now similarly, if I use here benzene as a reactant, benzene. All of you know the what a well-known compound, very famous compound in organic chemistry. It's a benzene. Alternate carbon-carbon single and double bond arrangement. Right? When it undergo ozonolysis, O3 in presence of CCl4, first of all we'll get Hurt-like structure. In this case, we'll get three Hertz. Three Hertz. One ozone can break two covalent bonds, so addition of ozone takes place across carbon-carbon double bond. So here we need actually three molecules of ozone. So our intermediate compound will be like this. It's a carbon, it's a carbon, carbon. This carbon-carbon single bond remains as it is, right? Similarly, this carbon-carbon single bond also remains as it is, and this carbon-carbon single bond also remains as it is, as it is. Addition of ozone occurs across carbon-carbon double bond. So we get three hertz. O dash, then dash, then dash, then O and O. One hut, first hut, here is that second hut, and we'll get one more hut. And that will be over here. Oxygen, dash, 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 oxygen, oxygen, and oxygen. So it is a triozonide. What is this? It's a triozonide. Triozonide of which compound? Benzene. So it is called benzene triozonide, which on reductive cleavage by using Zn and H2O. Cleavage occurs like this. Okay, here also like this. In this case like this. In this case like this. So, and next cleavage will be over here. So we need a three. If you balance it, then we need three atoms of zinc, which will couples with three oxygen atoms, giving three ZnO, which on decomposition by three water molecule gives three molecules of zinc hydroxide. And we'll get our main product, that is the product of interest, which will be C. Don't forget that each carbon carry one hydrogen atom. Okay, each carbon carry one hydrogen atom, so it becomes C H and O, single bond C H and O. We'll get CHO CH per unit. From this side also we'll get same CHO and CHO, and from here also we'll get CHO and CHO. So we'll get three molecules of this compound CHO, single bond CHO, and along with this we'll get three molecules of ZnOH twice. Now what is this? This compound is called glyoxal. It is called glyoxal. Okay, and if I carry out oxidative cleavage of it by using hydrogen peroxide, then this glyoxal is going to oxidize into what? Corresponding acid. Just convert CHO group into COH group. So we'll get three molecules of this, and this compound is an oxalic acid. It's a oxalic acid. So it's about reaction of benzene with ozone. That is the ozonolysis of benzene. Got it? Very good. Now let's have alkyne. The simple alkyne, or the first member of alkyne series, is a CH triple bond CH. It's acetylene. It is called acetylene, or its common name, IUPAC name, is a ethyne. Acetylene or ethyne. On ozonolysis, in presence of CCl4, it gives intermediate compound, that is ozonide, which is like this. Now here in this case, our hut is going to have some support at the middle. That is this support. As I said earlier that one ozone molecule can break two covalent bonds, but alkynes are the compound in which there are three covalent bonds between two carbon atoms, of which two undergo cleavage by one molecule of ozone, meaning one carbon-carbon bond remains unaffected. So here it is the structure of ozonide in the case of what? Alkynes. So alkynes on ozonolysis, once again like alkenes, they give ozonide, and which on decomposition or reductive cleavage using Zn and H2 gives us. Yes, so tell me what will happen? This CO bond, this CO bond, and this OO bond undergo cleavage, but this CC bond remains as it is. So you get CHO and CHO, and this O couples with Zn, giving ZnOH twice. So you get same molecule, that is CHO, which you got in that previous example, that is ozonolysis of benzene. We'll get one molecule of this compound, so it is a glyoxal. It's a glyoxal, and plus we'll get our same secondary product, that is zinc hydroxide. And if I carry out oxidative cleavage, then this glyoxal is going to oxidize into what? Oxalic acid. Follow? So it's a reaction of what? Alkyne with ozone. Okay? Reaction of alkyne with ozone. Hope you understand the reaction. Now suppose if I have this alkene, can anybody guess the product of this reaction? That is O3Cl4 is the first condition, and the second condition is given as a Zn and H2O, meaning yes, that ozonide is going to reductive cleavage. So how to identify product directly? What we have to do? We have to break this carbon-carbon double bond. Then we have to add one oxygen out of these three oxygen, one oxygen on this carbon. We have to bond doubly, means this carbon or this oxygen is doubly bonded with this carbon. Similarly, second oxygen will be doubly bonded with this carbon. Okay, and don't forget that here in this case, here is one hydrogen atom and here are two carbon atoms. Okay, so give one oxygen to this carbon, other to that second carbon, and both oxygen will be doubly bonded with that carbon. And forget about third oxygen, that is going to couple with that zinc, giving ZnOH twice. So the product of this reaction are like this. We'll get this compound, double bond O and then dash. Okay, CH3, CH2, CH2, CH3, CH2, CH2, then C will be doubly bonded with this oxygen and then carbon. That is, we'll get 3, 4, 5, pentanone, pentan 2O. Okay, it's a pentan, pentan 2O, and plus we'll get this double bond O and then H, CH3, C double bond OH. So what is that? That is acetaldehyde. That is acetaldehyde. Now why we're getting mixture of two different carbonyl compounds? Yes, because our alkene is not symmetrical. It's a unsymmetrical alkene. Okay, got it? Now suppose if I have this alkene on ozonolysis, same condition, Zn, H2O, Cl4 will be there. What will happen? Yes, break this double bond, put one oxygen on left, other on right, and both will be doubly bonded with that respective carbon atom. So you'll get CH3, C double bond O, and here is H, you'll get acetaldehyde. And from this side also you'll get same acetaldehyde, CH3, C double bond O and H, because our alkene is symmetrical alkene. So you get two molecules of CH3, C double bond O and H, acetaldehyde. Okay. Now guess the product of this reaction. What will be the product of this reaction? Final products. Check symmetry of alkene, unsymmetrical alkene. Breaking takes place across carbon-carbon double bond, one oxygen on left, one oxygen other on right. Okay, you get CH3C double bond O, and here is H, and here is a CH2. You get CH2O, that is formaldehyde. So you get two different aldehydes. One is a formaldehyde and the other one is this, that is acetaldehyde. Because our alkene is not symmetrical, it's a unsymmetrical alkene. Got it? Yes. Now suppose if I give you product, if I ask you a question like which among the following alkene on ozonolysis gives mixture of this CH3, C double bond O, H and plus CH3, CH2, C double bond O and H. Okay, what is my question? Which among the following alkene on ozonolysis gives mixture of acetaldehyde and propionaldehyde? What is this? It is called propionaldehyde. It is a propionaldehyde, and the first one is acetaldehyde. Propionaldehyde and acetaldehyde. Okay. So as ozonolysis of certain alkene, we have to identify that alkene giving what? Mixture of two different compounds. So it clearly indicates that alkene is going to be unsymmetrical. Okay. Yes. So how to identify the structure of that alkene? What we have to do? We have to arrange these two compounds in such a manner that we can easily remove that two oxygen. Okay. So it is an acetaldehyde. It's acetaldehyde, and we arrange them in front of them. O double bond C, C double bond O over here, and then H, and here is that CH2 and CH3. Right? Same compound, same compound. It's H. It's H. H. Then I remove this to oxygen. Remove this to oxygen atom and extend these double bonds. So this is our alkene, which on ozonolysis gives mixture of these two. That is CH3. Look at this CH3, then CH, then this double bond, then again CH, and followed by CH2, and followed by CH3. What is this? 1, 2, 3, 4, 5. It's a pentene. It's a pent-2-ene. Correct? It's a pent-2-ene. Followed? So guess the product of this reaction. This on ozonolysis gives. Yes. Breaking takes place across carbon-carbon double bond. So you'll get this. As alkene is not symmetrical, so you'll get this C double bond O, one oxygen on left, other on right. Here is the CH2, CH2O, that is formaldehyde. So you'll get this. That is cyclohexanone. What is this? It's a cyclohexanone, and plus you'll get CH2O. CH2O, that is formaldehyde. CH2 and O. You get formaldehyde because our alkene is not symmetrical, so that's why we're getting mixture of two different carbonyl compounds. Okay? Yes. Now let's talk about importance of this reaction. As I mentioned at the beginning of my lecture, that this reaction called ozonolysis reaction, it is very useful in predicting the position of carbon-carbon multiple bond in organic compounds. Okay? With the help of this reaction, it becomes easy to identify the position of, or to identify or to check the unsaturation, location of that unsaturation in organic compound. Okay, so it's all about ozonolysis reaction. Hope you got some idea about this ozonolysis reaction. So if you like my video, if you like my channel, then please subscribe it and share it with your friends. Okay, thank you.